Hi everybody, this is Mr. Beckstrom, and today I'm going to take a look at an example from section 8.2. This is similar to number 7, and here we have two equations with 3 unknowns. So since I only have 2 equations but I have 3 unknowns, I know that I'm going to get a dependent solution. That means that the x, y, and z are all going to be dependent on what I put in for either x, y, or z. In order to get a finite number of solutions or exact solutions, I would need at least 3 equations in order to do that. So since I only have 2 equations here, what I'm going to end up doing is I'm going to use one of these as my independent variable, and then the others will be my dependent variable. So in this case, I'm going to go ahead and solve for y and z in terms of x. That way we can let x be anything we want, and then we can solve for y in terms of x, and we can solve for z in terms of x. Now technically you could do the same thing with y or z, but the actual answers in the my math lab give it in terms of x, so that's why we're doing it that way. So the first thing that I want to do is it looks like I can pretty easily get rid of these y's. That way I can get the answer for z in terms of x. So in order to get rid of the y's, I can multiply the second equation by -2. So if I do that, if I multiply this equation by -2, that's going to give me the second equation is going to be -4x plus 2y plus 2y minus 4z is equal to -10. And the reason I'm doing that is because if I add this equation now to the first equation, it's going to get rid of my y's there. That way I'll only have z's and x's. That way I can solve for z's in terms of x. So adding the first equation with this new equation that I just got by multiplying the second equation by -2, I'm going to get -3x. That's going to be plus z. And that's going to be equal to 6 and -10 is -4. And then solving for z, I'm going to add 3x to both sides. So z is equal to 3x minus 4. And now what I want to do is I want to solve for y in terms of x. So I want to get rid of the z. Now I could either do the same kind of thing and figure out a way that I can multiply both of these equations by something in order to cancel out these z's. So I could multiply this second equation by like a -5 and this first equation by a 2, and then that would give me a 10z and a -10z. That would work. Or I could just substitute this into like that first equation there for z, and then that would turn this z into a 3x minus 4, getting rid of my z's in the first equation, which is what I'm going to end up doing. Both of those are completely valid ways of doing it. So I'm going to take that first equation here. So x minus 2y plus 5, and remember, instead of z, z is equal to 3x minus 4. Don't forget to put it in parentheses so we remember to distribute, and that's equal to 6. Alright, so now we just have to do some algebra. 2y plus 15x minus 20 is equal to 6. And then we're going to have 16x minus 2y is going to be equal to, add the 20 to both sides, so we get 26. So I get -2y is equal to -16x plus 26. Divide through by -2, and I get y is equal to 8x minus 13. And there you go. So this is what my solution set is going to look like when I put it in here. And I'm going to show you how I'm going to put it in too. So what I'm going to do is, let me put it back up here. I'm going to put it in B. So the solution set is x. I can put in any x, and then for that x, my y is going to be 8x minus 13, and my z is going to be 3x minus 4, where x is any real number. And this should be it right there. If you have any questions, let me know, and have a great rest of your week. Thanks.